So, hello everyone. This is Janani J, studying in Sri Venkateshwara College of Engineering. So today the YouTube video is about a topic related to system software subjects. The topic is illustrate algorithm of recursive dis and parser with backtracking. There is an example provided. I've given an example too. So let's get to the slides. So these are the steps. These are the steps included. So first step is to initialize the parser with the input string and the starting non-terminal symbol. So the next is create a recursive procedure for each non-terminal symbol in the grammar. Inside each procedure, perform the following steps. So inside each procedure, there must be the ABCD, all these 4 steps should go accordingly. So first one is we should check if the current symbol matches the expected token from the input. If it does, if the current symbol is matching with the expected token, then we got to consume the token and move to the next symbol. If it is not matching, then backtrack and try another production. Didn't change the other thing, change it to the other thing. Then if the current symbol is non-terminal, recursively call the corresponding procedure of that non-terminal. So if it is a non-terminal, just call the corresponding procedure of that non-terminal. If the current symbol is an epsilon production, return without consuming any tokens. So if it is an epsilon production, then we have to return without consuming any token. Over here, what exactly it is like, if it is a non-terminal, then call its corresponding procedure of that non-terminal, and if it is an epsilon production, without return without consuming any tokens. If all symbols of in the production are successfully matched, then it is a yes success, return success. Then the next step is start parsing by calling the procedure for the starting non-terminal symbol. If the parsing is successful and all input tokens are consumed, return success. Otherwise, return an error. The same thing is like repeated. We got a if the parsing is successful and all input tokens are consumed, then we get a return success. Otherwise, it is going to be an error. So here, recursive decent parser with backtracking is a top-down thing. That uses recursive procedures to parse input based on a grammar. It tries to match the input with the grammar rules by recursively calling the procedures for each non-terminal symbol in the grammar. If a procedure fails to match, it backtracks and tries an alternative option. So with backtracking, it is a top-down approach. It uses a recursive procedure to parse input based on a grammar, and then it tries to match the input with the grammar rules by recursively calling procedures for each non-terminal symbol. If a procedure fails to match, it backtracks and tries on the alternative option. So now let's see an example. So here is the grammar provided. This is the thing. Let's see with this example. So we're gonna consider this input id plus id into id. We're gonna make the steps for this according to the algorithm. Start with the non-terminal e, and then we're gonna write procedure for e. Here is the procedure for e. Then you're gonna write a procedure for e dash again. So yeah, if next token equals plus, and match plus parse t function, parse e prime, else epsilon production return. So whatever I said earlier, they've given in this code kind of thing. We're going to write a procedure for t and then a procedure for t dash as well. This is the procedure for f. If the next token equals bracket, then there's an else if ll. If it is invalid, they've considered as they've written an invalid token. So that is the thing. Implement the match function to compare the next token from the input. Then we got a match function compared to the next token, and then start parsing with the initial call to parse function e. Then here's the thing: we're gonna print if it is success, then parsed successfully, print valid input, else invalid input. So this is the thing for today's video. Thank you. That's it.